nine, eight, seven, six, five, four, three, two, one.
Hello and welcome to day 5 of the Newchip Accelerator Q4 Online Demo Day Global Startup Conference. My name is Armando Vera Carvajal and I'm the Accelerator Director here at Newchip. We're excited to have hundreds of investors and entrepreneurs here joining us from every corner of the world this whole week. And this has been our biggest demo day to date. 110 global startups from the Newchip Accelerator have been pitching to investors this week. And this also includes 25 industry panels and guest speakers participating in a diversity of discussions focused on addressing key issues today in the startup world. To kick off today, day 5, it is an honor and true pleasure to introduce a truly remarkable guest who has undeniably impacted the life of everyone on this planet today by inventing the underlying Ethernet technology that has brought the internet to billions of people worldwide. Without further ado, it is both an honor and pleasure to welcome Bob Metcalfe to this special keynote talk. Bob, thank you so much for joining us today.
Thanks for inviting me.
Absolutely, it's a pleasure. Before we dive in, I'd love to share some details on your background to share some context with our global audience.
Keep it short though.
I'll try. You have a very, very impressive bio, so I'll try to keep it short. But Dr. Robert Metcalfe, or Bob, is Professor of Innovation in the Texas Innovation Center, which he founded in 2011, and Murchison Fellow of Free Enterprise in the Cockrell School of Engineering at the University of Texas at Austin. He is Professor of Entrepreneurship in UTAustin's McCombs School of Business. In the Texas Innovation Center, he is the principal investigator of TexasGeo.org, which aims to solve energy once and for all, using startups to advance cheap, safe, clean, abundant, ubiquitous, deep, closed-loop, baseload geothermal energy. Earth produces enough heat to power the human race 24/7 for billions of years, or until Sol or the sun goes supernova, whichever comes first. More prominently, Bob was an internet pioneer, beginning 1970 at MIT, Harvard, Xerox, Palo Alto Research Center, Stanford, and 3Com. Bob invented Ethernet at Xerox Parc on May 22nd, 1973. Today, Ethernet is the internet's standard plumbing and now adds, especially if you let Bob count Wi-Fi or wireless Ethernet, billions of standard internet ports per year. Bob has won the Hopper, Bell, Marconi, Stibitz, and Shannon Prizes. Very, very impressive. He is a life trustee emeritus of MIT and a member of the National Academy of Engineering. In 2005, Bob received the National Medal of Technology for his leadership in the invention, standardization, and commercialization of Ethernet. Notably, Bob founded 3Com Corporation in Silicon Valley on June 4th, 1979, and he took the company public in 1984. After all sorts of organic growth and M&A, 3Com revenue peaked at $5.7 billion in 1999. 3Com's market capitalization also peaked in 1999 at an inflation-adjusted $52 billion. Of which Bob didn't even get half. 3Com was acquired by HP in 2010 and is now part of that conglomerate. During the 1990s, Bob was also the CEO, publisher, and columnist at IDG InfoWorld magazine. His column about the internet from the ether was for 8 years read weekly by more than 1 million information technologists among IDG's 90 countries. During the 2000s, Bob was a limited venture general and now emeritus partner at Polaris Partners in Boston. Wow, what an impressive background, Bob. It's, again, such a pleasure to have you here today and to also see you after meeting you several years back as a student of yours at the University of Texas at Austin. To start this talk off, I want to jump right to the fact that you helped pioneer the internet. There's just no way the world would be where it is today without the advancements you helped bring forth. As the father of the Ethernet, also a world-renowned entrepreneur, and also a widely acclaimed academic, did you ever imagine you would find yourself where you are today, back when you were starting your career as a student at Harvard and MIT?
Well, it's been a long journey, since I started working on the internet project formally in 1970. So that's, how many years is that? That must be 50 years. And I'd like, many of my colleagues claim from time to time that they had a vision back then about how it was all going to play out. But I went to all those meetings. No one had any idea the internet would blossom to where it is today. It's been a succession of surprises, which, by the way, is guidance for today. That is to expect surprises,
right,
and to surprise people with your innovations. Actually, my work on the internet started even before I worked on the internet. I mean, I was well educated. I went to MIT undergraduate and was well prepared to help build the internet. And help build is the operative phrase there. Many, many people have worked on the internet over the last 50 years. And we're starting to fight over who invented it, That flares up now and then.
But you built it, right? You're the one who did it.
The whole thing. Yeah, that's
the
right.
whole thing. Yeah, no, I mean, it's really fascinating, as you said, to take a step back and look at how far we've come as a modern civilization. In hindsight, everything always makes perfect sense, but in the present moment, it can be quite challenging to connect the dots ahead. Back then,
in a meeting, excuse me for interrupting, I was once in a meeting where we were talking about Vint Cerf as the father of the internet, which is, I would credit him with that. And there was this guy in the room and he said, "That's rubbish. Vint Cerf couldn't possibly have typed in all that information."
Oh. Yeah. And I imagine a lot of information. Kind of going back to the 1970s, when you were pioneering this new ether technology, as it was coined back then, did you imagine that the future would be like it is today, with an interconnected world of smartphones, online platforms, video streaming, all running on the internet?
Well, Ethernet was not designed to carry voice or video. And in fact, we resisted it for a while. And the status quo, principally at Bell Labs, told us that Ethernet could never carry voice, of course. And we agreed with them, actually, because, you needed 150 millisecond end-to-end delay. And Ethernet all had retransmissions and stuff that would interfere with it. So for the longest time, it was thought that the voice, video, and data were the three main industries. Voice, mostly telephone; video, mostly television; and data, the big computer companies, mostly IBM. It seemed that they would persist as three separate industries. And big surprise is they did not. Over time, they converged because it turned out that Ethernet could carry voice and it could carry video. In fact, today, the internet is mostly video. I don't know what the number is, but it's like 80 or 90% video, thanks to Netflix and YouTube et al. So there's count that as a huge surprise in the evolution of the internet. When we were building the first versions of the internet in the 70s, there was no World Wide Web. The World Wide Web wasn't invented till 1989. 89, which is not 70. And it really didn't even take off till Netscape went public in 94. So now there is a miracle there. You may remember that the internet, the World Wide Web was basically three standards: URLs and HTML and HTTP, three sort of mediocre standards that clicked. And they worked perfectly starting in 1989 on top of TCP, IP, and Ethernet, which had been invented in 73. So look at the gap of time between 73 and 89. So that's another surprise, that the old plumbing it's hard to get rid of the old plumbing. We still have it today.
Right. No, I mean, and it's playing such a big role in where we are today. Recently, the internet hit its 50th anniversary. You talked a little bit about convergence. What kind of disruption and innovation do you foresee over the next decade, let alone the next 50 years, resulting from the rapid pace of internet connectivity?
Well, we've gone through a series of pretty awesome disruptions already. I mean, famously, journalism, for example, has no business model anymore, and so it's a mess. Someone's going to have to figure that out. So book sales have completely changed. I remember when people said, "You'd never buy a book online. Going to the bookstore is just so much fun." Well, not. And, so there have been a series of disruptions.
Yeah.
The three major industries have been converged. That's huge.
Mm-hmm.
But now we're entering a phase where the impacts are going to be even bigger. And I generally list them as three:
Okay.
education, energy, and healthcare, which are all much bigger than telecom. And you can almost feel it starting already. COVID was a big accelerator on education. I mean, we academics have been dragging our feet for a long time about using online education. And now suddenly everybody is using online. It became possible overnight. How could that be? Just overnight. So MIT and Texas and others are all, if not, well, maybe most of the classes are now all online suddenly. And we're learning a lot about how to do that better and better and better. So that's the beginning of, the acceleration of internet learning taking over from bricks and mortar education.
Mm-hmm.
And so now we just won't go K-12, bachelor's, master's, PhD. We're now going to be lifelong learning.
Right.
I think degrees will fade away and we'll have various. I recently ordered my college transcript from MIT. So I have a little piece of paper that shows all the courses I took.
Oh, wow.
Grades I got. And so you could imagine the modern version of that, where you show your employer, what you know based on, of course, you won't say, I have a degree from the University of Texas at Austin. You won't say that because that won't mean as much. More and more it'll be, well, what did you study? What do you know? What can you do? So that's a big trend. And then there's energy. And energy is, we're going to solve it. We're going to solve energy in the next 50 years the way we solved information in the last 50 years. That is I call it the internet, the energy network. Mm-hmm. So the internet's beginning to emerge, and it has similarities to the internet. I mean, for example, at the beginning of the internet, there was no storage. In the internet, as I mentioned earlier, you had to send the telephone call through at 150 milliseconds period. But then we introduced storage, servers and terabytes on your cell phone and so on. And the internet is basically interconnected storage with some processing. Well, the energy network storage is beginning to emerge as a prominent factor in the evolution of energy. We have intermittent supplies of energy from solar and wind, for example, and we have intermittent demand for energy as a function of season and daylight. So storage moderates the randomness on both ends of that network. So the big three: education, energy, and then healthcare. Healthcare is a horrible mess, right? And the getting everybody interconnected, giving people their own information, and then using the network to cure diseases. You're seeing it go on right now, where the reach of the network allows you to learn more about diseases very quickly.
Right. And I mean, industry is very much in need, especially here in our country. You mentioned those three different industries, which I absolutely agree will be key to the next 50 years. But in terms of some of the more fundamental drivers for technological convergence, I know you mentioned storage. Are there any other sort of underlying drivers today that will really change the game?
Well, the march of, Ethernet is about to go to 800 gigabits per second.
Mm-hmm.
It started out as 2.94 megabits per second in 1973. Now it's approaching 800 gigabits per second. And that continued march is a driver, since you asked about drivers. And build it and they will come. We introduce faster networks and new applications arise that take advantage of the better reach, lower costs, higher speeds of the core network. So that's driving. Moore's law is driving, and it's not slowing down. My theory is that the principal driver is connectivity.
Yeah.
That is, connectivity is itself a thing.
Mm-hmm.
We need to study it more carefully. And I pose a paradox. I call it the transistor neuron paradox. Transistors are 10 to the 11th times faster than neurons.
Mm.
And if not 10 to the 11th, maybe it's only 10 to the 10th faster than neurons.
It's still fast.
Switching times. So the neuron is just a very much more capable node than a pitiful evolutionary neuron. However, neurons can make brains and transistors can't. Transistors don't even come close to making brains. And what's the difference? The difference is connectivity. Billions of years of evolution have caused the neuron to figure out how to get connected to other neurons and to the other parts of the body. Whereas our transistors, we don't have connectivity figured out. So I think another driver will be us figuring out connectivity and thereby increasing the capacity of our network systems.
Yeah, and also fueling the depth of artificial intelligence, machine learning, and how that also helps drive it further with the connectivity and the storage. You mentioned something very interesting a moment ago, Moore's Law. There's also a famous law named after you, Metcalfes Law, and it's a well-known axiom that explains how the value of networks increase as the number of connected users grow. What exactly does Metcalfes Law, your law, truly mean to you in terms of the big picture for technology?
First of all, I didn't call it Metcalfes Law, but it first appeared as a 35 millimeter slide in a sales pitch that I distributed to my sales force in 1982-ish. It became Metcalfes Law in a book called Telecosm by George Gilder in 1995. But ever since then, I've been defending it to the hilt. Metcalfes Law basically says it's good to connect things together. Mm-hmm. And then it attempts to quantify that by saying the goodness, the value grows as the square of interconnected things. And for the longest time, no one bothered to test my law, unlike Moore's Law, which has been numerically correct since 1965. But then a few years ago, I checked it. I managed to fit the first 10 years of Facebook's growth, its revenues as a surrogate for value and its monthly average users as a surrogate for connected users. And bingo, it fits Metcalfes Law and a few other papers. Anyway, it's good to connect things together and it's bad to disconnect them. So occasionally you hear about the subdivisions of the internet, and that's not good news because that will reduce the value for everyone. Yeah,
no, and that makes perfect sense. Do you think that only applies to just technology, or can that method in theory be applied to connectivity in general, like real physical communities?
In general, I mean, it also recurses. You can think of Facebook as one big network and observe value emanating from its complexity. But then the individual Facebook groups, they're also, there's evidence they also grow as the value of them grows as the number of participants in them, roughly as the square.
Right.
So no, it seems to apply in many, but it's not important whether it's exactly the square or not. And there's a gazillion grad students who are arguing whether it's n squared or n to the 2.4, 2.2, well, whatever. It's just good to connect things. And that was the whole point of this 35 millimeter slide in 1982 was I had to convince people to buy more of our products. And I argued that their networks were not as useful as they had hoped because they weren't big enough.
Yeah.
And the remedy for that was to buy more of our products, which they did.
And it worked. It absolutely worked. Kind of going on that same vein, I wanted to talk a little bit about 3Com Corporation, which you founded. Provider of internet hardware, software, including the first commercial implementation of TCP, IP, and first Ethernet for PCs. I mentioned when I introduced you that you IPO'd in 1984, you hit nearly $6 billion in revenue in 1999, and then you merged with HP. Tell us a little bit about the journey that you experienced, all the way from launch to exit acquisition.
Well, I could put in my resume that I worked from 3Com from 1979 through 1990, but I really had 20 different jobs in that period of time. I mean, that was the best part of it. I mean, I was the sole employee for 6 months, and that was lonely. And then we were a consulting company for a while, and we grew to 10 people, and that was a different kind of thing. There were other people to deal with. And then we started making products. Then we raised outside venture capital. And while this is happening, the company's growing and everything's changing. So we reorganized. In the beginning, we organized every 6 months. And then as we got bigger, we reorganized every month. We switched from a functional organization to a subdivision or organization. And we kept going back and forth. And the company changed. I got to be chief executive for a while, president for a while, chairman for 8 years. Then VP sales and marketing for 2 years. That was the best time of my life right there. And then I became the software division manager, and then the division manager for workstations. We built a workstation. Then I became the division manager for all hardware. Then I became VP of corporate marketing. That was my last title there before I retired out. Retired is not the right word, before I left in 1990. So a great part of having a company you've started grows. You get to play many, many different roles and learn a lot while you're going along. One of my standard jokes, which you may have heard, is that I really enjoy working for huge companies that I founded.
Who doesn't, right? That's I think it's just so fascinating to see, especially your trajectory, right? How you went from being a solo founder for 6 months, a long time when you're doing it all alone, and then gradually growing the team, and then effectively delegating it all and taking different, I would say perhaps more minor roles as you let others take on leadership of the company. What was sort of like your thought process in delegating as the company grew over time?
Well, a key idea is I don't know if you're going to get this. Have you ever driven a car that has a clutch?
Yeah. Standard.
It has first, second, third, fourth, fifth, sixth gears, and it has RPMs and MPHs.
Yeah.
So take that as a metaphor.
Mm-hmm.
As you grow your company grows faster than the people. Mm-hmm. Unlike a big company where the people grow faster than the company. Big, important distinction. Right. You have to be sure that people in their jobs are not redlining. Mm-hmm. In other words, as the company grows, some people don't have the skills or experience or temperament to hold the big version of their job. And that's the equivalent of redlining your engine. Time to shift gears. Of course, shift gears is putting a different person in. Now, sometimes when you do that, the person you've replaced leaves the company in a huff. And sometimes they just take some other job that's better suited to them. My favorite example, you used the word earlier of, what was it? Did you say demoting less important jobs? We had one quarter we desperately needed sales. We didn't have any. So they made me head of sales and marketing.
Right.
The first thing I do is I recruited a guy named Dave Depew, who was a production engineer. But his dad had been a salesman.
Yeah.
And he was single and he could move anywhere tomorrow. So I made him head of East Coast sales, this production engineer. So here's Dave. The next day he flies there, gets an apartment, sets up shop, starts selling. And by the way, it succeeded. He succeeded. He succeeded so much that his next assignment was to be the head of Northeast regional sales, which you may recognize as half of what he had before.
Right.
Now, was he demoted? No.
Mm-hmm.
The territory he had, even though it was geographically smaller than what he had before, was much bigger than the one he had taken over. We were growing 300% a year. So even though from the top, it looked like he was being demoted, from the bottom, he was enjoying the growth of the company and being promoted and succeeding step by step, which is very unusual. Right. Very unusual for engineers to make good salespeople, and he did. So did I, by the way. I made the same transition, though at a different time, from engineer to salesperson.
Yeah, I mean, and it's fascinating to see. And I'm wondering, like, has this type of trajectory changed, or do the fundamentals still apply today to most other tech startups?
I don't think you have to be careful with taking advice from people like me, because we learned there then, and this is here now, and here now is not necessarily the same as there then, but I think this idea of gear shifting as a metaphor for people management in a rapidly growing company. You must be prepared. You must detect when people have redlined. It's very complicated to decide if they have, like, if a sales territory underperforms, was it because the salesman wasn't any good, or his quota or her quota was too high? Well, you have to decide that. That's a judgment call. There's no book you can read about that. And so is that person redlining or not? Do they just need better tools or different shaped territory, or what do they need? So that's the process of deciding whether someone has redlined. If they have redlined, you got to get them out of there, because they'll hold your whole company back. Right.
I agree. And it's a crucial perspective to have in a startup. Bob, you've also served as a GP at Polaris Venture Partners. Throughout that time, I'm sure you looked at many deals, and you're also an investor today. What's the single most important factor that you seek when backing an entrepreneur with your investment?
By the way, I am no longer an investor today.
Okay.
In the history of venture capital firms, there's a thing called distributions. Mm-hmm. You get your money back. It's actually the hardest thing to do. You raise the money as a VC, and then you give it out to the startups, and then you get it back.
Right.
Getting it back is the hardest part. In any case, I'm in the distribution phase of venture capital. I get regular checks from Polaris, irregular checks from Polaris, as we liquidate investments that were made 5, 10, 15 years ago. But the question you ask is a standard question of venture capitalists. What do you look at? The people, the technology, or the market? And there are 3 kinds of venture capitalists. There are those who focus on people, those who focus on technology, and those who focus on markets. The good ones, of course, consider all 3 with different weights on them. And my preference, although I'm not sure it was a strength, was I focused on the technologies, assuming we could shift gears if we needed to, that is, replace the people. I'm one of those VCs that entrepreneurs hate because I'm not founder friendly. Even though I was a founder myself, or maybe because I was a founder myself, I don't think founder friendly is necessarily a good thing if you're trying to. One of the ways that I attracted investors is I told them the truth, which is that it was more important to me that my company be successful than that I run it. Mm-hmm. And so I was open to and very early attracted what we call in the Valley adult supervision. Mm-hmm. Bill Krause is his name. And a lot of founders don't like the idea of adult supervision. but they're wrong to do so. So, for example, one of the most famous CEOs of all time, Steve Jobs, he founded Apple in '73. He became CEO in '93. It took him 20 years between founder and CEO. He understood from day one the importance of adult supervision. If you look at the detailed history of Apple, you can see he had Markella at the beginning, and then Scotty, and then famously John Scully, and so on. He brought in his adult supervision, and that's an important technique. So I had my adult supervision, Bill Krause. When Bill joined the company, there were 12 of us. We were a little nervous about it, how he was going to spoil everything, because he insisted that we plan things, for example. Mm-hmm. When Bill got kicked upstairs, we kicked him upstairs to chairman later. The company went from 12 people to 12,000 people under his management. So, he succeeded wildly, actually.
Big change. No, and I think it's so true. The adult supervision part, I think we see this a lot, right? We work with hundreds of different startups in the Newchip Accelerator, and most of them understand, right, that they should not be the smartest person in the room, that there's going to come a point where they have to step aside, and somebody else who does have the chops or the experience to take that company from small to big, to titan, will require them to move to the side. And I think it's just so valuable that you also share that perspective.
And by the way, this is a highly statistical matter, and there are exceptions to every rule.
Right.
One of my favorite exceptions is a man named Ken Olsen, who founded a company called Digital Equipment Corporation, DEC, which is at one time the second largest computer company in the world. And he made it to the cover of Fortune magazine as Entrepreneur of the Century.
Wow.
That was the day that his board of directors should have retired him.
Mm-hmm.
But he had mistakenly filled the board of directors full of his friends. And he stayed CEO too long. And that's why you've never heard of DEC, because it went under. I mean, it got sold for a song. So it's really sad. Ken Olsen was the entrepreneur of the century, and then he just stayed on just a little too long past his he redlined, and no one shifted gears, and the company went away.
And it's interesting you mentioned that, because the way that I tend to hear it on the ground with entrepreneurs, it's this duality, right? You're either a visionary or you're an operator. More often than not, it feels like a lot of the entrepreneurs, the founders, are the visionaries. They have the vision. Sometimes they'll have the operational know-how. But as you mentioned, there comes a point where you stay on a little too long, and somebody else has to come in and fulfill that role.
If you're running your company and your board members start referring to you as a visionary, that means they don't want you to run the company. So you can expect very shortly to not be running your company, because visionaries don't make good operators.
Right.
So beware. If you want to run your company, don't get pigeonholed as a visionary. For Pete's sake, never tell anybody, and especially members of the press, what your vision is. Do not refer to your vision as your vision. Let me call it a vision, but don't you call it a vision. That's way too, what is it? Help me. What is that? When someone says, well, my vision is, don't tell me you have a vision.
Right.
Oh, well.
No, yeah. And I think that really ties in to the whole notion and concept that really comes down to ego, right? Because a lot of the founders who stay on as CEOs for too long, it's about me, right? Like, this is my baby. I created this. I have the vision for it, and only I can really take it to success. But that tends to be the pitfall, slippery slope for a lot of founders, and they kind of, like DEC, stay stuck, right? And just that entrepreneur of the century, and they don't actually advance the company to greatness.
Well, ego is a two-sided coin. It is the nuclear energy that drives things. It is also the road to ruin. So somehow keeping one of the Silicon Valley VCs who I visited in preparing to start my company told me as a general rule, there were three things that cause companies to fail.
Yeah.
And one of them was a lack of focus. want to do too much. One of them was a lack of capital, which they were prepared to fix by investing maybe. But the third one, and they all mentioned it, was the ego of the founder. That is, the ego of the founder can be limiting. It's also driving. So once again, it's a two-sided thing. The ego is a driving thing, but it can be a fatal flaw eventually.
Right, right. And there needs to be that fine balance. On a somewhat similar vein, you coming from the innovation world, what is the power of a crazy idea? And why do we need more crazy ideas today, now more than ever?
Let me change your question just slightly. Why would somebody buy products from a startup? Why would they take the risk? Why would they do that? I know the answer because I've seen it. I was out selling Ethernet to bankers and retailers at a time when personal computers did not exist and PC Ethernet was never heard of. But I watched, and then later when I became a publisher of InfoWorld, they were my readers. These are the technical people willing to go out onto the bleeding edge. Why do they risk it? Why do they innovate? Why do they innovate? Why do they risk buying junk from startups instead of from IBM? Why do they do that? And the answer is they have competition. They want to beat their competition, and they think that you hope they think, that your whatever you're selling is a tool that they can use to advance their careers, they can use to advance their companies versus the competition. So it's competition, the answer to your question. Competition drives people out onto the bleeding edge of technology.
Yeah, it's that fundamental driver that has made us where we are today. And I would even say the creation of the internet, Ethernet, it was that drive to get that technological edge that is moving us forward. And you can see it with space, you can see it with lots of different industries and ideas that were perhaps at some point in time considered absolutely crazy and unimaginable and are now a matter of fact today here on Earth.
Going back to the big version of your question though, there's this wonderful chart that I've included in my connectivity briefing. It shows the number of people connected by the internet, which is an exponential that ramped sharply starting in 1994 with the advent of the web. And there's another chart of the number of people who are in deep poverty. Mm-hmm. And that number grows slowly with the population for decades. And the internet arrives, and the number of people living in extreme poverty nosedives. It goes down. So even though we may have 1 billion people in extreme poverty, we used to have 2 billion and 3 billion. So that's another reason to innovate is, in the particular innovation we're talking about now, is connecting people together. Right. You do it to make human lives better so that people don't have to live in extreme poverty. Now, there are people who like to point out to me that correlation and causality are not the same thing. And just because this plunge in extreme poverty came after the rapid growth of the internet and the World Wide Web doesn't mean it caused it, but I think it did cause it. Mm-hmm. And correlation is a hint about causality. So it isn't causality, but very often correlation leads to causality. And I think so. One of the reasons we built the internet and increased human connectivity was so that we could all live better lives. Right. Competition is good. Right. And so the secret to progress, since you asked, is FOCACA, FOCACA, freedom of choice among competing alternatives. Mm-hmm. It's not Yiddish, FOCACA, it's an acronym. So I have learned that if you want progress in any field, in art, science, engineering, etc., competition, freedom of choice among competing alternatives is the way to maximize progress. Yeah,
I mean it's a very important perspective, I think, and it's a trending topic right now everywhere, especially this year with the rise of COVID-19 and the impact it's had on many people. Historically, government has played a pretty major role in fostering economic growth in both science and technology. Do you think that today, as a nation here in the US, we're on track to continue the development of the next generation of technological research and innovation, or are we falling behind?
What's happened is good. What's happened is good news. And the good news is that our competitors in the world are catching up to us, if not beating us in some areas. So we are still not bad. I mean, the operation of the National Science Foundation, the National Association of Venture Capitalists, all the instruments of innovation and economic growth, as far as I can see, are still functioning. The good news is that our competitors are doing better than they used to. So now China has as many universities, has as many MITs as we do, more MITs than we do. And that's good because innovation leads to peace and prosperity. So the more innovation there is around the world, we can expect the more peace and prosperity, I think. So it's not that we're falling behind, it's that they're catching up and as I mentioned, in some cases, surpassing us.
And to that point, which I think is extremely valid, what should our government, regardless of partisan affiliation or ideology, understand in terms of financially and institutionally backing the next generation of startups and entrepreneurs across industries?
It's interesting how you asked that question. You said, in other words, you tried to keep me from mentioning that it's a matter of ideology. It is a matter of ideology. I mean, should the government be sponsoring research? I think it should be. How much should it be sponsoring? That's complicated and it gets worked out. What goes on in governments to determine how much money we spend on research and where it goes is a messy, really messy thing, but we do it really well in the United States, I think. And so I'm getting all tangled up in the research and development infrastructure of the United States government. And, there's some stupid things going on, but mostly it's really good people implementing time-tested processes, like the preeminence of ARPA. I've seen ARPA working since the 70s, and it's still working. That's good to have an ARPA, the Advanced Research Projects Agency, Department of Defense. Now, there's some things that are a little worrisome. A peer review, for example, is broken. And peer review is one of the basic principles of the evolution of science. And I'm not expert on it, but I can see that peer review has become corrupt. You have people approving each other's papers, friends on review committees, things getting approved without being read, crap like that.
Right.
And so that needs fixing. The irreproducible results ratio is going up. That is, the papers are getting withdrawn with greater frequency because they turn out to be false. So that's a topic that interests me, is how can we keep that system working as well as it has been over the years, and it's showing signs that it needs repair.
Many structural constraints that need to be fixed to make it easier for people to innovate in science and technology. Bob, to close this talk out, in 2005, you received the U.S. National Medal of Technology for leadership in the invention, standardization, and commercialization of Ethernet. This is obviously an incredibly prestigious award offered to the few creators behind some of the most pivotal technologies today. As you look ahead into the future of technology, what words of inspiration might you share with the next generation of technological pioneers and innovators?
I do want to insert a wonderful thing that happened as a result of that medal in 2005. It came soon enough that my parents could go to the White House with me to receive that medal and to go to the parties that surrounded the various people who got medals that day. My parents never went to college. They were the children of immigrants. They believed in the American dream, and here they were. I have this picture of my mom wearing the National Medal of Technology. And I have figured out, by the way, that my principal motive, even though my parents are gone, is to please them. And to have my mom at the White House wearing this medal was, the culmination of the American dream. So I'm a big proponent of the American dream, and going back to your question, would advise people to believe in it, to believe in freedom. So it's a positive loop. Freedom and prosperity. Freedom leads to prosperity, and prosperity leads to freedom. And innovation is the connection that drives them. So so it's a good thing to be an innovator. So it's a high calling, and you should, especially an engineer. By the way, there's this false dichotomy between scientists and engineers, and they don't like each other. Hilarious. It's a false dichotomy. The best scientists are engineers, and the best engineers are scientists. And the siloification of the university into the School of Science and the School of Engineering is a bug. That's a bug in the system. Anyway, you should be an engineer. That's my advice. You should be an engineer for a bunch of reasons, one of which is it pays. Engineers get paid. Very few engineers are driving Ubers. Second, it's fun. It's like solving puzzles every day. You have the problems, so there's the joy of mastery. And third is engineers are solving the world's problems, and that's a high calling. So the world has problems, and engineers fix them. So be an engineer.
I love it. That was brilliantly said, and I absolutely agree with the thoughts you shared about being in the White House with your parents, and that being the driving motivation. One, which I also share, right? It's being an immigrant here in America. Like, when people give everything to come to this land of freedom and opportunity, like, you want to do everything to please them and make their sacrifice worthwhile. So it's so good to hear that coming from you as well, Bob. Thank you so much for joining us today and sharing your time, your insights, perspectives. This has been very profound for me and for the global audience. And thank you to everybody else who tuned into this talk, investors, entrepreneurs from around the world. We hope that you found this talk very, very valuable. Bob, thank you once again, and we hope you'll join us again soon.
Thank you very much.